1.5. Mrs. McDonald, what do we have this week?
This week we are featuring subtracting mixed numbers. We added them last week.
We did.
Now we're gonna subtract.
Probably some of the same strategies we're going to see, but
Yeah.
we're just going to subtract. And there's our first problem. What is the difference of 9 5/6 and 3 2/8?
Well, I'm going to take a crazy guess. That difference means subtraction because we said we were going to subtract mixed numbers. That's a pretty bad subtraction sign. But let's kind of fill that word "and" in.
So whenever we see the word difference, know that it means subtraction.
Make a big fat subtraction sign.
All right. So last week we kind of had different ideas about how to solve these problems.
Right.
And I think we're going to show you both methods and you choose which one you prefer.
Okay.
There is the McDonough method
My method.
and the Marino method, my method. Let's get started.
All right. So we're going to show you the steps here before we do it today. In my method, there are 5 steps, and the first step is to rewrite the mixed numbers as improper fractions.
And we learned how to do that in the first video, so if you don't remember, 1.1.
And then after we do that, we're going to make sure they have common denominators, because remember, you can only add and subtract fractions if the denominators are the same.
I remember that.
Yeah. Then we're going to rewrite the fractions as equivalent fractions
So that we have the same denominators.
when we're changing them to the common denominators. Yes.
Mm-hmm.
Yes, indeed. And then we're going to subtract. And remember, with fractions, once you have the denominators the same, you only subtract the numerators.
Mhm.
And then if we need to, we might have a top-heavy improper fraction that we need to rewrite as a mixed number again.
Right. All right. Here's our problem again: 9 5/6 and 3 2/8, and we already decided that we're going to subtract.
Yeah, so that's a subtraction problem.
So step 1 for you is writing improper fractions. Can you remind me how to do that?
Yeah, you take the integer that's in front of the fraction, and the shortcut method is you multiply it by the denominator of the fraction, and then you add the numerator of the fraction. Oh, sorry. So in this case, we'd say 9 times 6 is 54, and 54 plus 5 is 59.
Okay.
So we have,
And what happens to my denominator?
it stays the same.
Okay.
And then we're going to subtract, and we are going to do the same thing to this set of integer fraction combo, this mixed number. We're going to say 3 times 8 is 24,
Mhm.
plus 2 is 26. That was my subtraction sign. Sorry. What did I say, 26 over 8.
Oh, right.
Okay. Now we have 2 improper fractions that we made from these mixed numbers.
So I can check off part 1.
Oh, yes.
Beautiful.
Oh, you can do it yourself. Wow. Now, the next step is like denominators, or getting the denominators the same. which they
And
are
we
not.
have been doing that in every single weekly since weekly 1.2.
Yeah.
So if you don't remember, look back. We're going to show you one more time though.
So the method that we use is to take the larger denominator and then start counting up, or skip counting by that number, counting up multiples. So we'll have in this case 8, 16, 24,
32.
and it's getting a little off kilter here. And that should be enough. Then we're going to take the other denominator and see if it divides evenly into any of these. Well, it doesn't divide evenly into 8. It does not divide evenly into 16, but ding, 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 divides evenly into 24. Because 8 times 3 is 24, and 6 times 4 is 24. Now,
We can check that off. We found our like denominator. It
we
is
know when it's
24.
too big. Okay. So I'm going to put the 24s down here to remind us that that's what we're headed for. So how are we going to get this fraction to have a denominator of 24?
Let me pick a different color. Because we counted 3 times, I'm going to multiply my denominator and my numerator
Yep.
times 3.
Boy. No. Little side calculation there.
Mhm.
78. Yep. 78 over 24. Okay. that same color over here, we're going to have to multiply this, sorry, we're going to have to multiply 59 over 6 by an equivalent fraction.
Which would have to be 4?
Yes,
Over 4?
sorry, I'm getting distracted by the pens again. That is right. There's going to have to be a 4 in the denominator in order to get 24, and we've got to have 4 over 4, so that we're only multiplying the fraction by 1. So 59 times 4,
Well,
If
50
it were-
times 4 is 200,
yeah.
and 9 times 4 is 36.
You're good.
So 236?
Man,
Little
you-
mental math there,
you're
isn't it
like-
fun?
You must be a
Didn't
math
work so well
teacher or
with these
something.
ones.
So that's,
Wow.
we have 236 minus 24. Can you move the page down for me a little bit
Minus
up there? I'm sorry,
78.
minus 78 24.
All right.
So remember, because our denominators are the same, we are all set to go with the subtraction, which we only do across the top. So we know we're going to have something over 24.
We might want to do a little side
I think we're going to need
calculation
to do
here.
some, we have to, 16. 158.
Over 24.
Now that is certainly an improper fraction. 'cause
That is a large improper fraction.
158 is much bigger than 24. I'm not seeing immediately any kind of obvious way to reduce it except to divide, they're both even, so we could divide each one by 2
Mhm.
in an attempt to reduce this.
And we would get something over 12. 75 and 4, so 79.
Yes, sorry, 79 over 12. And that is still an improper fraction, but now I feel like it's a little easier to see what to do because we know that 12 goes into 79 6 times
Mhm.
because 12 times 6 is 72, and then there will be 7 left over. So we
So-
can call that a
6.
mixed number. That is 6 and 7/12.
And if you do not remember how to turn your improper fraction into a mixed number, look back on video 1.1 and we taught you there.
Sorry, that was supposed to be a star.
Beautiful, that is a nice start.
Didn't come out very well.
So your method works really well, but there are some big numbers.
Yeah, you know, with these bigger numbers, there are a lot more of these side
There
calculations.
is a lot of
Do you have to
calculations
do
that
that
have
with
to
your
happen.
method? Do you have to have these side calculations too?
Let me show you my method and
All right.
you can see. So did we complete all our steps?
Oh,
We
sorry.
made equivalent fractions, we
Didn't keep up there with
subtracted,
my
and
checklist.
we rewrote.
Yep.
So yes, we followed all our steps and we got an answer.
Mhm.
Let me show you my method.
All right.
My step 1 is to make like denominators. So
Okay.
pretty much like yours. Then I want to create equivalent fractions by multiplying. Step 3, I might have to borrow. Now I don't think we will need to on the first problem, but
Okay.
on the second one.
Okay.
But we'll talk about that when we get there. Step 4, we're going to subtract. And step 5 is to make sure that our answer is in simplest form. Because we always want to have our answer in simplest form at the end. You don't want to leave it as an improper fraction. You don't want to leave it as a fraction that can be reduced. So make sure that you watch out for that. I've been getting a lot of weeklies turned in that were not in simplest form.
Oh.
So back to our same problem. 9 and 5/6 and 3 and 2/8. And we said it was a subtraction problem. So I'm going to rewrite it as 9 and 5/6 minus 3 and 2/8. Good so far?
Yeah.
Right. First step, like denominators.
I know.
Just like you. I have 8 and 6. Tell me all about it.
I think it's 24.
You think it's 24? All right. So we have 24 as our like denominator. And we need to multiply times something to get 9 and something over 24 and 3 and something over 24.
Mm-hmm.
Now,
So you're just changing the fractions and kind of leaving the integers out of
you
this.
can leave the integers completely alone.
Okay.
So we end up with much smaller numbers to work with, which
Yeah.
works well.
Yeah, 5 times
6
4.
times 4,
It's going to be easier.
5 times 4, I end up with 20. 8 times 3, 2 times 3, I end up with 6.
Mhm.
And then we had already said it was a subtraction problem. And, ready? You take your whole numbers and subtract them. 9 minus 3 is 6. You take your numerators, 20 minus 6, 14. And you already told me that we keep our denominators the same always.
Right.
So 24.
That doesn't look exactly like what I had done.
It's pretty close though, because we didn't follow our last step yet. We went through, we have like denominators, 24.
Mhm.
We made equivalent fractions over 24 over 24.
Mhm.
We did not have to borrow for this one. We subtracted.
Both the
We did
integers.
not have it in simplest form yet. So if you look
Reduce
at
it.
14 and 24, they're both even numbers. So I know I can divide by 2.
Yes.
And my whole number stays the same. 14 divided by 2 is 7. 24 divided by 2 is 12.
That sounds familiar.
And that is the same answer you got.
Yeah, great.
So again, whichever method you choose is the one that you feel more comfortable with. We both have different ways of getting to the answer, but since our answer is the same, it doesn't really matter which one we choose.
Yeah, and we both follow all the math rules on the way there, so that's why we get the same answer.
This one is just a little bit smaller numbers to work with,
Right.
so it doesn't become so convoluted.
And I think you don't use calculators on your weekly, right? So,
We do not use calculators,
so
no.
that's another argument for yours on this one anyway.
So let's move on to example 2. And tell us, Ms. McDonough, what are we going to do?
Well, this time we are going to subtract again, and now we have a subtraction sign showing that clearly. I'm going to try and do it using your method this time.
All right, well, I have my checklist up there, and you can use that. But I
Okay.
think I have your checklist first, so why don't I try your method?
Sorry, I want to start over.
Okay, let's start over.
Okay.
Okay, ready?
Example 2. Now we're going to do another subtraction problem.
Yeah, looks good. How about I try your method?
Okay.
Okay, so I wrote down your lovely checklist, and I'm gonna try to follow it, and you guide me along the way.
Will do.
Because sometimes I might get stuck. So step 1 says, write it as an improper fraction. And I remember this. You said I'm gonna multiply my whole number by my denominator, and I'm gonna add my numerator.
Mm-hmm.
So 8 times 10 is 80, plus 6 is 86. And over my denominator stays the same.
Stays the same, right?
I'm subtracting 3 times 3 is 9, plus 2 is 11, over 3.
Mm-hmm.
Step 1, done.
Good work.
Step 2, I need to make like denominators. And I think I'm going to count them kind of over here. My bigger one is 10, 20, 30. I'm going to stop right there because I see that 3 goes into 30.
Yeah, that one will work.
So you like to rewrite them by writing your denominators like this.
Yeah, kind of get them ready.
So now we're ready. I just need to figure out what to multiply by.
Right.
Ooh, these are big numbers. So this one is times 3 because 10 times 3 is 30.
Mhm.
And I can't do 86 times 3 in my head.
That's all right. You can do it on the side.
3 times 6, 18. 3 times 8 is 24, 25.
Mm-hmm.
258?
Yep.
We're good?
Beautiful.
So I have 258 right there. I'm going to use another color. This one, 3 times 10 is 30. Whatever I multiply my denominator by will also become my numerator. And that one I can do in my head. 11 times 10 is 110.
Good.
Good so far?
Yeah, you should check off, I think, number 2 and number 3.
Oh my gosh. I made like denominators and I rewrote them as equivalent fractions with like denominators.
Indeed.
Now I need to subtract. I think I'm going to have another site work here. We have 258 minus 110. Actually, that one was easy.
And you're just subtracting the numerator because the denominators stay the same.
148.
Mm-hmm.
And I end up with 148 over 30.
Very improper.
Very, very improper. But I think before before I start turning it into a mixed number, I want to simplify.
Yeah.
Because I noticed that both of them are even numbers.
Right.
So I'm gonna divide by 2,
It's always a good place to start.
and I'm gonna break this up. 140 divided by 2 is 70. 8 divided by 2 is 4, so I'm thinking 74,
Mhm.
and half of 30 is 15.
And then the only factors that could divide into 15 are 3 and 5, and I don't think either one of them will divide into
Well, it's
that.
not a 5 and a 0, and
Yeah.
7 plus 4 is 11, and because 3 doesn't go into 11,
Yeah.
that
So-
one won't work.
So that's in lowest terms as a fraction, however, it's an improper fraction.
It is very improper, so I remember way back when in weekly 1.1, we did long division,
That's right.
like this. And if I go 15, 30, 45, 60, 70, so 4 times. And that becomes 60, and I am left with, right there, I'm left with 14. And then my mixed number should be, this becomes my whole number. This becomes my numerator. And that stays my denominator. I end up with 4 and 14 over 15.
That looks right to me.
You know, it wasn't so bad. I thought it would be a lot more scary with all those big numbers like that.
You can handle
But-
big numbers.
It really is nice just to worry about the 2 fractions and not have the whole numbers in there.
Yeah.
So I like that.
Well, let me try your method because I haven't done it your way before. So if you can talk me through, I'm going to try this same problem. Everybody remember 4 and 14/15. See if
Okay.
we can get back there again.
So I made you a wonderful checklist for that one too.
Thank you.
So let's start with step 1.
All right. Now I seem to recall that when you did this, you rewrote them as a subtraction problem, top over bottom, like this.
Yes.
And we're going to subtract the whole numbers and then subtract the fractions as a separate operation. But first we need like denominators.
Mhm.
And I know because you just figured it out that 30 is a great denominator in this case. So I am going to say I multiply by 10 here and by 10 here. So I'll have 20 over 30.
Sounds good.
3 and 20 over 30. And here I multiplied by 3, so I have to multiply by 3 up here as well. So this will be 6 times 3 is 18 over 30.
Very good.
Well, things are getting a little crowded there already, Ms. Marino, so I think I'm going to rewrite
Let's rewrite it. We have
down
8
here.
and 18 over 30. And we have 3 and 20 over 30. And I think you can check off some of our steps that we already did.
Yes. We found the like denominator
We
of
did.
30, and we multiplied by unit fractions to get equivalent fractions that are going to be better for adding together, or rather, excuse me, subtracting because they have the same denominator. Maybe borrow, what's that mean?
All right, so let's look at this. Remember how I said the first one we didn't need to borrow, but for the second one we needed to?
Yeah, oh,
So our problem we end up with here is that 18 minus 20 doesn't really work out. We can't
Oh.
take 20 away from 18.
right, this fraction is actually bigger than that fraction.
So we need to borrow from our whole.
Well, that's what we would do if we were just subtracting integers from each other. That's
Exactly,
true.
so it works exactly the same way.
Okay.
So do you want to do it and I'll just walk you through it?
Yeah, so I'm going to borrow a whole 1 from this 8 probably,
So
right?
how many will be left then?
Well, there'll be 7 left here.
Perfect.
So I'm going to just make a note of that up there.
But we need to write something over here that shows us that we had that 1.
Yeah, we borrowed that 1 and we're going to take it over here. And I don't want to just write plus 1, right?
You want to probably write it as a fraction. So how can you rewrite 1 as a fraction over 30?
I got it. Does need to have a 30 in the denominator.
Right.
But if it also has 30 in the numerator, it's equal to 1. And I took 1 away from here, and then I just put it over here, and I'm going to add it on to this fraction.
Right, so you end up with 7.
7 and rewrite the whole thing over here, right? 7
Yep.
and 18 plus 30, 48 over 30. Sorry, that 4 is a little shaky
I think
there.
our smartboard is off a little bit today.
And then this one, we're not going to do any borrowing with this bottom one because it's
And we
already
need a
set.
30 right there.
Oh, sorry, yes. So 7 and 48 thirtieths minus 3 and 20 thirtieths.
Perfect, and now you can go ahead and subtract.
So I'm going to subtract the whole numbers here. 7 minus 3 is 4. And 48, and they're both over 30, and that stays the same. So let's put that denominator down there already. And then the numerators, 48 minus 20 is going to give us 28.
Beautiful.
And I'm thinking that both of those numbers can be divided by 2 to make this
Because we have
reduced
even numbers.
fraction. Yes, because they're both even. So I think that this can be rewritten as 4. 28 divided by 2 is 14 over 30 divided by 2 is 15. That sounds familiar.
I think that is the same answer that we had earlier.
Yay, we did it.
We did do it, and we checked off all our steps.
I like your method.
We borrowed.
The borrowing was a little tricky, but if you just take your time and think it through, you're just moving a 1 from the whole numbers over the fractions, and you have to
Mhm.
rewrite it once you get it over
Right.
here.
Then we subtracted, which is really easy.
That's easy.
And we just have to reduce so that we have everything in simplest
Yeah.
form.
And a good way to start with the reducing, if you're not sure if they're big numbers, is what we did here, say, oh, they're both even, we know we can at least divide them both by 2, and then
Right.
look at what you get. There, you might be able to do it again, or divide a 3 in, but in this case, we got 14 over 15, which certainly can't be reduced.
Very nice. If you have any questions, please come see me during lunch or at any other time that you make an appointment for. And watch the videos. If you get stuck on any of these, go back, watch some of the old videos where we also explain things so you can see more examples. And we will see you again next week. All
See you
done.
then.